Meron tayong bagong project. Ano na naman yan? Ha? O ito. Ang tawag dito ay reverse polarity protection circuit. Okay? Ang ating power supply 18650 battery. Diba? Oh. Meron tayong load LED module. Ginawa ko lang yan. Homemade. Tingnan natin. Ayun oh. May resistor LED 10 mm in size. Oh. Di ba? Lagay natin. Ayun. Meron din tayong MOSFET IRFZ44N N-channel type MOSFET. Sa likod, merong resistor, dalawang LED na maliit, 3 mm in size at mga resistor. Current limiting resistor. Oh. Oh, yan ang ating project. Ba't ayaw umilaw? Yun. Oh, yan na naman ang ano niyan. Siya ngayon ay nasa tamang polarity. Ibig sabihin, yung ating supply in a right polarization or in a right polarity position. Positive at negative. Kaya umilaw yung LED green. Tama yung polarity niya. Ibig sabihin ng polarity, yung positive, talagang sa positive, negative sa negative. Okay? Paano kung wrong polarity? Mali yung pagkakakabit ng battery. Gawin natin yung positive ng battery sa negative. Negative naman. Oh. Ayun. Umilaw yung kulay red na LED. Ibig sabihin siya wrong polarity. Mali yung pagkakabit ng battery. Oy, anong maganda dyan? Aba? Ginamitan natin ng MOSFET para maproteksyonan yung ating circuit sa maling pagkakakabit ng battery or due to the wrong battery connection. Yan ang ating bagong project. Diba? Ayan umilaw yung LED red. Pag tama ang polarity, balik natin, positive sa positive. Umiilaw yung LED o yung load. Pag maling polarity, hindi siya umiilaw. At mayroon pang wrong polarity monitor, LED. Basta kulay red, wrong polarity. Kulay green, right polarity. Correct polarity. Correct connection of battery. Iyan ang bago nating project. Diba? Siya ay isa na namang magic. Magic ba yan? Simpleng-simple yan. Ayaw mo nun? Pag tama yung polarity. Kulay green yung ilaw. Umiilaw yung LED. Pero pag mali, kabaliktad ng kabit ng battery, protected na yung circuit. Hindi na umiilaw yung ating load na LED module. At merong indicator na siya ay wrong polarity. You know, oh, red. Di ba? Magic yan. Di ba? Okay, we have the reverse polarity protection IRFZ44N MOSFET and channel enhancement type circuit diagram. So this is the reverse polarity protection. We used the circuit in our testing. Okay, this is the MOSFET IRFZ44N, and it has a body clamp diode connected between drain to source and then the gate. As you can see in the circuit or in the figure, this is an enhancement type and channel indicated by the arrow pointing inward the circle, and the gate connected is the R3 resistor with a value of 10K. What is the use of this resistor in the circuit or to the gate of the MOSFET? It serves as a gate resistor or a biasing resistor, okay, to provide a pathway or a way for the leakage current. Remember that this is a voltage driven device. This is not a current driven device. So to produce a voltage, we need this resistor in order not to make this MOSFET to ring. There's a ringing occurs when there's no resistor to the gate. And into our circuit, this is the positive side of the circuit, then the negative side. We use this MOSFET when we are going to control the negative side of the circuit. So the negative side, that's why we use N-channel MOSFET. And here we have this right polarity indicator. Okay, this is the green LED, green, with a current limiting resistor of 220 ohms. And then for the reverse polarity, we have an R2 of this is red LED, and then I think it's 330 ohms. The value of the resistor. What's the use of this resistor and the LED? This is the load side of the circuit. So any load must be connected between the positive side of the battery and then to the source of the MOSFET. And as you can see here, the drain side of the MOSFET is connected to the negative side of the circuit. Why is that? Why is it connected in the negative side of the circuit? Because due to the operation of the circuit, if this MOSFET is connected in a wrong way, or it means that the source must be connected into the negative and the drain is here, it will not work properly because of the reverse current direction. There's a reverse current, while if it is connected that the drain is negative to the negative and the source is into the load, it functions smoothly as if we're going to connect a battery here. Then the positive flows into the load side and then the MOSFET to the negative. Okay, what happened if we have a right or correct connection of the battery? This is our battery and the voltage is 3.5 volts since this is 18650 battery connected this way, positive to positive side of the circuit. What happened to the circuit? Current flows into the resistor 1 and then to the green LED and then to the ground. So there is a complete circuit here because of the current flows into the resistor, then to the green LED and then to the ground, indicating that this is a right connection of the battery because the green LED turns on. So green LED turns on, right connection of the battery. Another current flows into the red LED. Will it flow? This LED now, which is a red, what is the polarity or the connection? This is reverse bias. Because the current flows into the anode to the cathode of the LED, while here it flows into the cathode to anode. So reverse bias. It's just like an open circuit. It will not flow into the red LED. So this is off. It means it is open. So LED red will not turn on. It is off. So the first thing, the green LED turns on and then red LED turns off because this is reverse bias. Okay, and then we have this gate. Current flows into the gate. What kind of current is flowing into the gated MOSFET? It is a leakage current. If there's a current that flows into the gate, it will produce a voltage, which is will open the gate and the current flows into the source to the drain. It will make to open the gate, that will make the current to flow into the source to the gate. So if the gate is open, the current now flows into the load blue. This is blue LED with a resistor of I think 3.3K current limiting resistor. So the current flows into the blue LED and into the source, and this will make this MOSFET to turn on because the gate is open due to the positive voltage induced into the gate, or there's a current flows, a leakage current that flows into the gate. Okay, this is a voltage driven. That's why there's a voltage developed across the gate to source and the gate to drain. So the current flows into the source to the gate, and then will that make this body clamp or internal diode inside the MOSFET to forward bias, and then flows back to the negative side of the battery. And the LED blue is on and the green LED is on while the red LED is off. Why is it turning on this MOSFET? Because of the voltage developed at the gate. There's a current that flows, a leakage current that flows into the gate. That's why it makes the gate to open and the source to drain to flow the current to the source to the drain and then to the negative side of the battery. That is in the right connection of the battery. What happen if we connect the battery in a wrong connection, or we connect the battery in a wrong way? As if we have the battery here, the negative is to the positive side of the circuit, and then the positive side now into the negative side of the circuit. So this is now the new connection. If we connect it, we have an incorrect connection of the battery or wrong connection of battery. The negative of the battery to the positive side of the circuit and the positive side of the battery to the negative side of the circuit. What will happen to the circuit? current flows into the D1, green, it will not flow into the green LED. It will turn off the LED because LED green is in forward bias condition. It will not flow. It is not in a forward, but in reverse bias condition, reverse. While the red LED will turn on because it is in forward bias condition. Current flows into the R2, into the red LED, and then back to this is now the ground because of the battery. Right? The connection of the battery is inverted. Now the negative side of the battery is connected to the positive side of the circuit, will make the current to flow into the red LED, and it will turn on the LED while the green LED turns off. What happened to the MOSFET? Since this is now a negative side, part of the negative side of the battery, it will pull down the gate to the ground. This is now the new ground because of the connection of the battery. So the gate is grounded. If this is grounded, current will not flow into the source of the gate or the drain to the source. As you can see here, there is no way to produce a reverse current direction because of the body clamp diode inside the MOSFET. That is inside the MOSFET, body clamp diode. There is no way. Only the red LED will turn on. Green LED turns off. MOSFET turns off because there's no gate voltage developed or current into the gate. It is grounded, 0 volts. If this is grounded, there's no way to make this LED blue, the blue LED to turn on. It is also reverse bias, grounded. Okay? So, in a wrong battery connection, only the red LED turns on. In a wrong battery connection, red LED turns on, green LED turns off, MOSFET turns off, and the load. This is considered as a load circuit. If we're going to make a block diagram for that, this is the positive side of the circuit, and then we have the reverse polarity protection or this whole circuit, and then we have the load. This one is the load. Okay, then we have the load circuit. This is the block diagram, positive, then flows back to the negative. So this circuit, load circuit, is this LED, and the reverse protection, reverse polarity protection is this MOSFET with the green and red LED monitor for on and off monitoring. So this is the block diagram, simple block diagram. What happened if we're going to connect a load? Since we know that our load is the LED module, what if the load is different? Will the circuit works? If we have a load circuit or a load module that is different from the LED module, do you think is there any possibility that the circuit will work using this MOSFET or reverse polarity protection circuit with a new load or module to be connected to this circuit? Here we have the new circuit. So instead of using LED module as a load, our load now is the LED flasher, one module connected to our reverse polarity protection. So it works. So this is now the circuit diagram I'm using with LED fader connected to the reverse polarity protection module. So instead of this load LED, we're now using LED fader, and it works because the current flows into the reverse polarity module, then to the LED fader, and then the ground of the LED fader is connected through the source of the MOSFET through here, just like the LED module. Okay? Let us now try to whether it can protect the circuit. So we reverse the polarity, the connection of the battery, negative to the positive of the circuit, and then positive of the battery to the negative of the circuit. Let us see if it protects the circuit. So you can see here, there's no LED fader, only is the reverse polarity protection LED red monitor or indicator. It indicates that the circuit is off, the MOSFET is off, and also the load is off. There's no reverse current in the circuit. Okay? Because of the MOSFET, the circuit is protected, this module. What if we're going to connect it again into the right polarity or right connection? Then we have now again the LED fader. This is the PCB layout for the module reverse polarity protection using IRFZ44N. I use this layout or this diagram for my PCB layout. For this reverse polarity with this type of circuit configuration, this is a low side switching of a MOSFET. So switching is in a low side, that's why the MOSFET is located into the negative side of the circuit, and this load it is sourcing current. So the load is sourcing current for the load passing through the low side switching type of a MOSFET.